All right, so here we are with our first example. Bill is a very good long jumper. Distribution of the lengths of his jumps follows a normal distribution with mean of 6.4 meters, standard deviation of 0.21. So I'm going to go and make a little sketch down here. It's not too bad. All right, here's my center. So I know that my center is at, put in here, 6.4 meters. That means my x-axis will be somewhere over here, but let's look at my standard deviation. Standard deviation 0.21, so one standard deviation away, 6.61. One standard deviation this way, 6.19. All right, keep going. Another standard deviation is going to be 6.82, and then that will be 5.02. No, sorry, 5.92. Okay, and then keep going. 7.03. And then the third standard deviation, subtracting 0.21, that's going to put us at 5.71. And I just want to make sure that I'm not about to give you faulty math. 6.4 minus 3 times 0.21, 5.77. Something is wrong. All right, did I get it wrong from the beginning? No, that's 0.19, and then 6.19 minus 5.98. There's my problem. Terrible math. 5.98, and then 7 there. Okay, so my empirical rule tells me that I'm going to have about 68%. More specifically, if I look up at this one, 68.26% is between these two values. So now I can see my x-axis would be way down, sorry, not my x-axis, my y-axis would be way down here. So I'm just, this line, I could put in, because it's not the x-axis, but it's the symmetric line for my graph. So between 6.19, 6.61, 6.19, 6.61, that's between these two values. That's within one standard deviation of the mean. So 68.26% of his jumps. 6.19 to 6.82. Well, now I'm adding in this section, and I know adding in each of those sections is another 13.59%. So we're going to have 68.26 plus 13.59. I won't even try this one. (81.85%). Okay, less than 5.98. That's going to be this region here. So I know that those two regions, 0.25 plus 0.13, that one I can do, 2.28%. So very few of his jumps will be less than 5.98 meters. All right, I'll come back in our next video. I'll do this example.